Okay, well, good afternoon, and welcome to this course on the philosophic corruption of physics. Now, you should all have a handout containing a course outline. And the outline has 5 parts corresponding roughly to the 5 lectures. I've also included at the end of the outline a reading list for those of you who may want to learn more about this subject. Now, the second outline I've handed out, you will not need until Wednesday, the 3rd class, where I'm going to discuss the issue of the atomic theory of matter and the opposition that arose to it in the late 19th century. So sometime between now and Wednesday, if you could look over that handout, you'll be better prepared to understand certain points that I'm going to make on Wednesday, but you don't need it for the first 2 classes. Now, no special knowledge of physics is required for this course. My goal is to present the ideas in such a way that both a PhD in physics and the novice will find them interesting and intelligible. However, I will rely on your familiarity with the objectivist literature. And in particular, it will be helpful if you know the essentials of the history of philosophy, as presented in For the New Intellectual by Ayn Rand and The Ominous Parallels by Leonard Peikoff. I will be explaining the ideas in the history of philosophy as I go, but I think if you coming in without having read those 2 works, the material will go by pretty quickly. Now, I want to start by briefly describing my purpose in this course. In 1934, at the age of 29, Ayn Rand wrote in her first philosophic journal, "As to physics, learn why mind and reason are so decried as impotent when coping with the universe. Isn't there some huge mistake there?" Unquote. Well, yes, there is a huge mistake there, or rather a long, complex series of mistakes over about a 150-year period. And the purpose of this course is to trace some of the main steps of the disastrous developments that led to Ayn Rand's question. Now, if you've read The Ominous Parallels by Dr. Peikoff, you understand the history of politics in the modern era. Politics reached its zenith during the Enlightenment, when John Locke's theory of individual rights led to the creation of the United States. You know that Immanuel Kant and the philosophers that followed him brought about the destruction of that achievement and caused the horrifying politics of the 20th century. Now, my theme in this course is that physics has undergone an exactly parallel development. The modern era in physics began with the achievements of a contemporary and friend of John Locke, Isaac Newton. And just as in politics, physics had the philosophic ground cut from under it by Kant and his successors. In politics, that led to brutal dictatorships. In physics, it led to the gleeful rejection of causality and the insistence that we live in an unintelligible universe. Now, the ambitiousness of my theme is both a problem and the strength of this course. On the one hand, the attempt to tell this story in 6 hours is sheer insanity. The pace is going to be so fast we should actually see relativistic effects. Room contraction, brain dilation. On the other hand, it's the whole progression from Newton through quantum theory that is interesting. If I just discussed the irrationality of 20th century physics, I would leave it unintelligible how physics came to such a state. So I decided to sketch the whole rather than go into any detail on a particular part. And you've all heard Hegel's aphorism, "the true is the whole." Well, in this course, I'm following Harriman's corollary, "the interesting is the whole." Now, why should you care about this topic? For physicists and students of physics, the answer is obvious. I don't have to motivate you. This material is essential to a fundamental understanding of your science. Now, it's true that many physicists today just use the equations without worrying about the fundamentals. But that's the attitude of a hack, not a serious scientist. And I know no one here has that attitude. But what motivation can I offer the majority of you who are non-physicists? Why should you care whether physics today is irrational? How does it affect you? Well, I think it affects you in 2 ways. First, you know that physics is the foundation of technology. The discovery of fundamental truths in theoretical physics can have an enormous practical value. Such discoveries fueled the Industrial Revolution, which has made our lives twice as long and immeasurably more enjoyable. Irrationalities in physics will, in the long run, bring such progress to a halt and thereby adversely affect your life. Now, don't ask me, if subatomic physics were rational, what life-promoting technology would come from it. I don't know. But I do know that in the long run, as physics goes, so goes technology. So there's a major value at stake here. Now, there's a second way in which the absurdities of contemporary physics affect you. In the Age of Enlightenment, physics served as the leading example of the power of reason. The basic content and method of physics and its spectacular successes sent a message that resounded throughout the Western world. Man can live and prosper by the guidance of his reasoning mind. Physics played an important role in giving rise to the exuberant confidence of an era known for creating beautiful art and political freedom. Now, in contrast, everywhere we look today, from the rise of pseudoscience and drug addiction and religious cults to the state of education in Hollywood and modern art, we see the rejection of reason on a cultural scale. Modern physics sanctions and reinforces that irrationality. Based on the achievements of the past, physicists had acquired the reputation for being leading spokesmen for reason, but now they have betrayed that trust. Today, crazy theories in physics are constantly being used to attack rational principles of philosophy. Anyone lecturing on the objectivist metaphysics will be told that the ideas are outdated. They have been proved wrong by physicists. They say, well, after all, Einstein showed that facts are dependent on the observer's perspective. Atomic theory has gone further and shown that there are no facts until the observer creates them. And what is all this nonsense and objectivism about the power of reason? Physicists have shown that the universe is ruled by chance and is therefore unintelligible. Go into any bookstore today and you'll find a dozen books written by physicists proclaiming that reality is a myth and that reason is helpless. Physics has become a foxhole for mystics and skeptics to hide in while they launch attacks on man's mind. Now, even without this course, I assume that none of you would fall for these arguments. Nevertheless, this nonsense is one cause of despair in the culture around you. It is undercutting people's belief that they live in a universe open to the human mind. That's what prompted Ayn Rand's question, and it should pique your curiosity about how physicists were led to such bizarre conclusions. Okay, well, now you're motivated and we're ready to start. Now, since my thesis is that Kant is the root cause of the irrationality in contemporary physics, you might think we should just dive right into Kant. But I decided that would be a mistake. Without the Rourkes of the world, what is there for the Tuohys to attack? So the story I'm telling here must begin with at least a brief discussion of the ideas that gave rise to physics in the first place. Then you'll know what the villains of the story are attempting to destroy. So we need to start with the hero, the man who was the greatest genius of the age of reason, Isaac Newton. Now, some of you may have taken my course on Newton a few years ago. And now you can sit back and laugh while I try to condense a 5-hour course into 20 minutes. In that course, I identified the essentials that make Newton the father of modern physics. And those essentials are, first, Newton's mathematical method. He invented the calculus, which is the language of modern physics, the means by which physicists can describe rates of change in physical quantities, and compute sums over continuous quantities. Second, Newton's inductive empirical method. He showed clearly for the first time that the abstract principles of physics can only be discovered by systematic observation and experimentation. Third, Newton's unprecedented scale of integration. That is, his discovery of universal laws of physics. Now, Newton's masterpiece, the mathematical principles of natural philosophy, or Principia, was published in 1687. It is without a doubt the greatest work in the history of science. It includes Newton's proof of his universal laws of motion and gravitation. And as most of you know, most of you know the two laws that I've written on the board here. This class will not have very many equations, but I couldn't resist putting these two up. Newton's second law of motion, which is that force equals mass times acceleration, and his universal law of gravitation, which is that gravitational force equals a universal constant g multiplied by the product of the two masses of the interacting bodies divided by the square of the distance between the bodies. Now, these are exact mathematical laws that apply to every bit of matter in the universe. Newton's discovery of them is an unprecedented achievement. No one before Newton had even conceived of such laws. And that's an important point to keep in mind. It was not that physicists prior to Newton were looking for such laws and just hadn't found them yet. They had no idea that such things were even possible. So Newton made a fundamental change to people's perspective on the basic goal of physics. Now, Newton showed in the Principia that these laws explain an enormous range of observed facts. In order to convey the scope of Newton's achievement, the way in which he forever changed our view of the universe, I want to give you a brief listing of the physical phenomena that Newton was able to explain. First, the orbits of the planets. Earlier in the 17th century, Kepler had discovered 3 laws of planetary motion that gave the correct mathematical description of the orbits. Newton was able to give a rigorous proof that Kepler's 3 laws describing planetary motion follow from his 1 law of universal gravitation. In other words, Newton began with Kepler's laws as the data for his induction of his universal law of gravity. Once he had the idea of his universal law of gravitation, he was able to show that Kepler's laws follow as a necessary result. Okay, number 2, the story of Newton and the apple that most of you have probably heard. Newton proved that the same force, the gravitational attraction of the Earth, explains both the moon's orbit and the rate that bodies fall to the ground here on the surface of the Earth. So Newton was able to give a rigorous proof that the same force, the gravitational force of the Earth, explained the acceleration at which the apple falls to the ground at the surface of the Earth and the acceleration of the moon in its orbit. That that ratio of accelerations could be explained by the Earth's gravitational force, assuming that force decreased as the square of the distance. Okay, number 3, the ocean tides. Newton showed that the tides are due to the gravitational attraction of the moon and the sun. He was able to explain all the basic characteristics of the tides. Why high tide occurs twice a day, why tides are higher in the new and full moon than during half moon, why they are higher in the winter than in the summer, etc. Now, prior to Newton, the tides were a complete mystery. Kepler had hypothesized that the moon caused them, but Galileo had dismissed it as another of Kepler's crazy ideas. As some of you know, Kepler was a Pythagorean mystic, and it was sometimes difficult to distinguish between his good ideas and his crazy ideas. But Kepler had made this hypothesis, but he was unable to make a convincing case for it. Newton came along and gave a rigorous proof. Number 4, Newton was able to explain the shape of the Earth. Newton realized that the gravitational force by itself would cause the Earth to be a sphere. If the only force acting on the Earth's mass was an attraction toward the center, the mass would arrange itself in such a way so that it was as close to the center as possible, which would make a sphere. But Newton realized that the centripetal force due to the Earth's rotation would cause it to bulge out at the equator and flatten at the poles. This is just the same effect that causes the clothes in your washing machine to go to the edges of the tub during spin cycle, right? Well, that's what happens to the Earth, pushing the mass out around the equator, causing the equatorial bulge. Now, Newton calculated the precise amount of the equatorial bulge. 50 years later, surveys proved him right. Okay, you should begin to be impressed. But we're not done yet. Number 5. Newton explained what is called the precession of the Earth's spin axis. Now, the Earth's axis of rotation is tilted with respect to the plane of its orbit around the Sun. This is what accounts for the seasons. For instance, the northern hemisphere is tilted toward the Sun now, which is why it's summertime here. Now, Newton figured out that this tilting of the Earth's axis with respect to the Sun, coupled with the Sun's gravitational attraction on the mass of the Earth's equatorial bulge, would cause the Earth's axis of rotation to cone around in a circle. Okay, so I've drawn a little picture here just to show off my artistic ability. And you see the Earth's spin axis tilted with respect to the plane that the Earth and the Sun are in. And the equatorial bulge, I've drawn the Earth in an exaggerated oblong shape here. The Sun's gravitational attraction on the equatorial bulge will tend to tip the Earth's spin axis more upright, more orthogonal to the plane with the Sun. Now that force, Newton calculated, will actually cause the Earth's spin axis to slowly cone around in a circle, wobble. Now Newton was able to calculate the period of that coning, and he figured out that it was 26,000 years for the Earth's spin axis to cone around once. And what that means is that 13,000 years from now, it will be wintertime in New Hampshire in July. So if you plan your vacations that far in advance, you have to take that into account. Now, it turns out that astronomers had actually been able to detect the effect that Newton had calculated here. Astronomers had realized sometime before Newton that the star positions were shifting slightly from what they expected. And sure enough, Newton's calculation of how the Earth's spin axis precesses around exactly explained those shifts in the star positions. Okay, what else? I've got one more for you. Number 6, the orbits of comets. Now, comets had always been regarded as mysterious and even of supernatural origin. Most people in the 17th century still believed they were signs of God's anger. Newton showed that the orbits of comets could be understood and predicted using universal laws that applied to all matter. In 1682, and this is just a few years before Newton published the Principia, there was a particularly visible comet. Starting from Newton's work, the astronomer Edmund Halley was able to predict the time of the comet's return 76 years later in early 1759. And it was a very dramatic event when the comet returned exactly on schedule. God's moods had gotten very predictable. Okay, now, what is the essential philosophic message implicit in the Principia? Now, you don't have to be a genius to get this. Newton beat you over the head with it. And I'll give you a hint. Ayn Rand called it the fundamental issue in philosophy. you said everything but what I'm looking for. The efficacy of reason. The Principia is a tour de force demonstration of the efficacy of reason. The greatest such demonstration in the history of science. Aside from the laws of physics that Newton proved, he proved the intelligibility of the universe, the unlimited power of reason to grasp the basic nature of reality. And the Principia hit the world like a bombshell. Even those who could not understand the mathematics understood its significance. Edmund Halley, who edited and published the first edition, expressed the basic message in an ode to Newton, which he included in the preface of the book. And let me read you just a couple of verses from Halley's Ode to Newton. Matters that vexed the minds of ancient seers, and for our learned doctors often led to loud and vain contention, are now seen in reason's light, the clouds of ignorance dispelled at last by science. Those on whom delusion cast its gloomy pall of doubt, upborne now on the wings that genius lends, may penetrate the mansions of the gods and scale the heights of heaven. O mortal men, arise, and casting off your earthly cares, learn the potency of heaven-born mind. Come celebrate with me the name of Newton to the muses dear, for he unlocked the hidden treasures of truth, so richly through his mind had Apollo cast the radiance of his own divinity. Near the gods no mortal may approach. Unquote. Now, I can only second Halley's reaction to Newton, and I can't say it any better than that. Halley gave Newton a much-deserved tribute, and he identified the main philosophic message of Newton's book, the potency of the human mind. Now, that message has a metaphysical corollary, that the universe is intelligible. And that brings me to my second philosophic point in connection with the Principia. Newton made possible a deeper, more profound understanding of the law of causality. The Greeks had understood causality, but in a qualitative way. Even Aristotle had said that his generalizations about the natural world were true, quote, always or for the most part, unquote. Now, the qualification for the most part was thought to be necessary for two reasons, one epistemological and the other metaphysical. Epistemologically, it expressed doubt about whether we could be certain of inductive generalizations about the physical world. Metaphysically, it expressed doubt about whether nature was 100% lawful. It left room for an element of contingency, accident, or chance. So even the Greeks did not grasp the full implications of causality. In the early 17th century, people were surprised when Kepler discovered that the planetary orbits could be described by mathematical laws. Kepler's explanation was that God loved mathematics and therefore designed the solar system accordingly. In other words, the fact that nature could be described mathematically was regarded as a miracle, not as a consequence of natural causality. But in fact, causality is the metaphysical basis for the mathematical description of nature. It's not a miracle that physical laws can be described mathematically. A mathematical law is simply an exact quantitative statement of our inductive generalization. Causality says that entities must act in accordance with their natures, not just most of the time, but all the time. And not just in a qualitative way, but down to every last detail, which we can describe quantitatively. Now, this is what Newton understood and demonstrated, that the universe is causal through and through, with no loopholes, no restrictions, no qualifications. Newton's discoveries made it possible to understand causality in its full glory. Okay, now there's a third crucial philosophic point to make in connection with Newton's physics, and it's a point that Newton made explicitly. He held, as a matter of absolute principle, that all scientific knowledge had to be based on observation. Now, to objectivists, that might not seem radical, but it was. Other 17th century scientists, Kepler, Descartes, even Galileo, did not accept that principle. Prior to Newton, it was very common for scientists to make arbitrary claims and then argue back and forth about them. New discoveries were often opposed because they conflicted with some arbitrary theory. For example, planetary orbits had to be circular, or colored light had to be a modification of pure white light. Now, Newton typically referred to arbitrary assertions as hypotheses. And explaining his terminology, Newton writes, quote, "The word hypotheses is here used by me to signify only such a proposition as is not a phenomenon, nor deduced from any phenomena, but assumed or supposed without experimental proof." And what Newton actually meant to say, I mean, the surrounding context shows that what Newton actually meant to say was without experimental evidence. Okay, now, Newton understood that accepting the arbitrary undercuts all knowledge, making it impossible to be certain of anything. Early in his career, he writes to a colleague, quote, "If anyone may offer conjectures about the truth of things from the mere possibility of hypotheses, I do not see by what stipulation anything certain can be determined in any science, since one or another set of hypotheses may always be devised which will appear to supply new difficulties. Hence I judge that one should abstain from contemplating hypotheses as from improper argumentation." Unquote. So Newton insists that the arbitrary be rejected without contemplation. Astounding. He's the only one in the history of, well, in recorded history that I know of prior to Ayn Rand that understood this point. Now, Newton laid down the following epistemological law to his colleagues. Any valid criticism of his physics must fall into one of two categories. Either it argues that his observations are insufficient to support his conclusions, or it cites further observations that contradict his conclusions. I quote again from Newton's correspondence. "The theory which I propounded was evinced to me, not by inferring 'tis thus because not otherwise. That is, not by deducing it only from a confutation of contrary suppositions, but by deriving it from observations positively and directly. And therefore I could wish all objections were suspended from hypotheses or from any grounds other than these two, of showing the insufficiency of observations to prove any part of my theory, or of producing other observations which directly contradict me, if any such may seem to occur." Unquote. Now, based on these comments and many others like them, I judge Newton to be the greatest epistemologist of his era, in addition to being the greatest physicist in history. Okay, to sum up, Newton's legacy transcends his incredible list of discoveries in physics, which I've barely had time to touch on. He left us with a philosophic legacy as well, by bringing about a fundamental change in people's view of the universe and in the power of the human mind to understand it. The world of Newton is an integrated universe ruled throughout by the law of causality, a sunlit universe completely open to the human mind, provided that every step of our reasoning is guided by the evidence of our senses. And Newton had an interesting perspective on his own accomplishment. He realized how much he had done, but he also knew how much more remained to be discovered. His last major publication was a brilliant list of ideas and questions to be pursued by future researchers. Many of the ideas were confirmed by discoveries made long after his death. At the very end of his life, Newton offered the following description of himself. Quote, "I do not know what I may appear to the world. but to myself I seemed to have been only a boy playing on the seashore, and diverting myself and now and then finding a smoother pebble or a prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me." Unquote. More than 200 years later, a jealous Albert Einstein began his preface to Newton's book on optics by exclaiming, "Fortunate Newton, happy childhood of science." Now, why was Einstein jealous? Well, in the intervening years, physics had lost sight of the great ocean of truth and had lost its innocence. And now we begin to look at how it happened. Any questions on Newton before I dive into the section of my notes entitled Philosophy Strikes Back?
Yes. Maybe it doesn't belong here, but wasn't Newton in his religious aspects arbitrary? Or in other aspects of
Newton,
life?
Yeah, I'm not making the claim that these aspects of Newton's epistemology that I'm stressing here he applied consistently across the board. I'm saying he applied them consistently within physics. And the interesting thing is that even, I'm going to talk a little bit about Newton's view of space and time at the end today. But this was the one fundamental error in Newton's physics, was his views of space and time, which he reified into independent things in themselves apart from the objects in space and time. But even in that case, it was not a mistake that he made due to committing the fallacy of the arbitrary. Newton actually gave very clever arguments for his ideas on absolute space and time. Wrong arguments, but among the cleverest wrong arguments in the history of science. So he definitely accepted the responsibility for arguing from observations for everything in his physics, including his views on space and time, even though they were wrong. So he held to this principle of rejecting the arbitrary and basing all scientific knowledge on observation very consistently. Yes?
In the quote that you gave, said that their identification as arbitrary, there was an inference that there was a widely understood view that in the realm of argument, of discussion, logic, that an arbitrary principle was to be, an arbitrary statement was to be ignored. Is that true?
Oh, absolutely. The question is, did Newton realize that the proper response to the arbitrary was simply to dismiss it out of hand? And that's exactly what Newton was saying in that one quote that I read. And that's the only way you can deal with the arbitrary. Newton understands that if you allow the arbitrary in for consideration, then it undercuts the certainty of every proposition in science and in knowledge generally. Because you can always come up with some arbitrary hypothesis that will contradict the knowledge you have. So he realized the only response to the arbitrary was to dismiss it out of hand without contemplation, as he says. Actually, I have to go on now, but if you can save those questions for later. Okay. Well, what happened next? And now we go into the philosophy in the 18th century. And let's start with the most influential English philosopher of the 18th century. In 1739, only 12 years after Newton's death, David Hume published his Treatise of Human Nature. Now, only quotes can do justice to a philosopher such as Hume, so let me read you some. Hume is upstairs in his study when he writes the following passage in the treatise. Quote, "I am seated here in my chamber with my face to the fire, and all the objects that strike my senses are contained in a few yards around me. My memory informs me of the existence of many objects, but this information extends not beyond their past existence. Neither my senses nor memory give any testimony to the continuance of their being. As I reflect on these thoughts, I hear a sudden noise as a door turning on its hinges, and then see a porter who advances towards me. This gives occasion for many new reasonings. First, I have never observed that this noise could proceed from anything but the motion of the door. And therefore, I conclude that the present phenomenon is a contradiction to all past experience unless the door which I remember still exists. Second, I have always found that a human body was possessed of gravity, which hinders it from mounting in the air, as this porter must have done to arrive at my chamber, unless the stairs I remember be not annihilated by my absence. Unquote. Now, Hume continues with this impressive line of reasoning, but you get the idea. He hears a door open behind him and then sees a porter. He infers that the porter opened the door. His room is upstairs. He infers the porter climbed the stairs. Now, compared to the inferences that we've seen Newton make, these results might seem modest. But that is not Hume's view. He examines these beliefs and concludes they are wild speculations without any rational justification. He writes, quote, "Nothing is ever present to the mind besides its own perceptions. The degree of regularity in our perceptions can never be a foundation for us to infer a greater degree of regularity in some objects which are not perceived. But whenever we infer the continued existence of the objects of sense, it is in order to bestow on the objects a greater regularity than what is observed in our mere perceptions." Unquote. So, according to Hume, we are aware only of a kaleidoscopic succession of sensations. Out of habit, we arbitrarily group some of these sensations together and call them objects. But we can never acquire any knowledge of a world that supposedly exists independent of our sensations, or validly infer anything beyond the sensations of the moment. He concludes this part of the treatise with the following, quote, "I have shown that the understanding, when it acts alone and according to its most general principles, entirely subverts itself and leaves not the lowest degree of evidence for any proposition, either in philosophy or in common life. The manifold contradictions and imperfections in human reason have so wrought upon me and heated my brain that I am ready to reject all belief in reasoning and can look upon no opinion even as more probable or likely than another. Where am I, or what?" Unquote. Well, we can answer Hume's question. No, I'm not going to answer it that way. Where? In the country of Isaac Newton. What? Unfortunately, the most influential English philosopher of the 18th century. Now, we have here an unstable situation, to put it mildly. On the one hand, we have the inductions reached by Newton, which allowed Edmund Halley to predict the exact time that a comet would return after disappearing from view for 76 years. On the other hand, the country's greatest philosopher claims to have no reasons to believe in the existence of a door when he has his back to it. Even when facing it, he claims that he's not aware of a door, but only sensations. Now, this was a crisis. The efficacy of reason was at stake here in a particularly obvious and dramatic way. There had never been a more urgent need for a great philosopher to come along and provide a proper foundation for the sciences. What the world needed was a thinker like Ayn Rand. What it got instead was Immanuel Kant. Okay, now we're up to Kant. In Kant's preface to the 1787 edition of the Critique of Pure Reason, he claims to have done for philosophy what Copernicus did for astronomy. Recall that in the 16th century, Copernicus initiated the modern era in natural science with a fundamental change in our perspective on the universe. He rejected the geocentric view in which all astronomical bodies revolved around the Earth and proposed a heliocentric theory in which the Earth and the other planets revolve around the Sun. Now, that change in perspective led to spectacular progress in astronomy and physics through the work of Galileo and Kepler, ultimately culminating in the work of Newton. Now, Kant says he wants to do the same for philosophy. And he's identified the root premise that caused all the problems in philosophy. The idea that our knowledge must conform to objects in a world existing independent of us. In other words, all the problems were due to the primacy of existence premise. If we rid ourselves entirely of that premise and consistently adopt its opposite, the problems will go away, according to Kant. In his preface to the Critique, he writes, quote, "Hitherto, it has been assumed that our knowledge must conform to objects. But all attempts to extend our knowledge of objects by establishing something in regard to them a priori by means of concepts have, on this assumption, ended in failure. We must therefore make trial whether we may not have more success in the tasks of metaphysics if we suppose that objects must conform to our knowledge." Knowledge of what? Blank out. Kant continues, "We should then be proceeding precisely on the lines of Copernicus's primary hypothesis." Unquote. Now, Kant called this his Copernican revolution. Now, if there ever was a big lie, this is it. The actual Copernican revolution was a triumph of the primacy of existence approach. It was brought about by looking outward, focusing on the facts, and rejecting rationalist dogmas. Its conclusion was that the universe is not centered on us and designed around us. It's a universe governed by natural laws that apply to the Earth and stars alike, laws that can only be discovered by observation. But Kant's anti-Copernican revolution consists of claiming that the universe is not only centered on us, it is in effect created by us. He was trying to cash in on the prestige of science to sell his version of the primacy of consciousness, and thereby reverse and destroy the achievements of the actual Copernican revolution. Now, Kant's ideas are specifically anti-Copernican in the following way. Kant gave an elaborate philosophic justification for the exact arguments that the Church had used to attack Galileo. Galileo's enemy, Cardinal Bellarmino, had argued that reality was the province of religion, not science. The role of science was merely to describe sense experience with convenient mathematical schemes. In a letter cautioning the advocates of the Copernican theory, Bellarmino writes, quote, "To say that the assumption that the Earth moves and the Sun stands motionless still saves the appearances is to speak well. This has no danger in it, and it suffices for mathematicians. But to affirm that the Sun is really fixed in the center of the heavens, and the Earth is situated in the third orbit and revolves very swiftly around the Sun, that is a very dangerous thing. It may injure the holy faith and render the sacred scripture false." Unquote. So you see what Bellarmino is saying here. He's saying it's okay if what you're claiming, Galileo, is that you've just come up with a convenient mathematical scheme for describing the appearances. But don't make the claim that you've actually reached the truth about reality. Truth about reality is the province of religion, not science. Now, Galileo would not agree that the heliocentric theory was only an assumed mathematical scheme. He said it was the truth about reality, and that was what got him into trouble. Now, Kant is explicitly on the side of the Church here. Reason and science deal only with appearances, not reality. Most of you probably know Kant's infamous line, "I have found it necessary to deny knowledge in order to make room for faith." Now, of course, the primacy of consciousness is not original with Kant. It is fundamental to Platonism and Christianity. Furthermore, the entire modern progression from Descartes through Hume held that we are aware only of sensory ideas or some kind of inner mental state, not external objects. The mind was regarded as an inner theater of ideas, and the problem was to infer from these ideas to the truth about the external world, which presumably caused the ideas. So consciousness was held to be an autonomous realm with only an indirect tie to existence. The opposite of what Harry Binswanger is saying in his lectures at this conference. But even though these early modern philosophers were wrong, there was still a crucial tie between consciousness and reality. Even if we only perceive mental states, it was still regarded as the goal of reason to figure out how those states were related to the actual objects in the physical world. Even if percepts did not give us direct awareness of the world, it was still hoped that concepts, reason, could grasp existence. When Hume argued that reason was powerless to do so, it was considered a disaster. Now, Kant was the one to reject every last remnant of the primacy of existence. According to Kant, it was not the function of reason to grasp existence. Concepts and percepts are completely cut off from the world and function within a realm of the mind's own creation. Now, what material does the mind begin with, according to Kant? What data provide the starting point of cognition? Now, for objectivism, obviously, this is perception. Perception of a world of entities around us. Kant, of course, doesn't believe that for a second. If you ask Kant this question of what cognitive data do we start with, he answers that the question is unanswerable. The raw material of cognition is unknowable and indescribable. Nevertheless, we can know that our minds synthesize this indescribable smear of unknowable stuff and create the world we experience. How do we do it, according to Kant? Well, first we have a faculty that supplies the spatial and temporal relationships, organizing the stuff so that we experience it in space and time. Second, we have 12 innate concepts, Kant's so-called categories, that synthesize the sensations into a world of entities that obey the law of causality and are amenable to our laws of logic. Okay, so the whole spatial temporal world is a product of our mind, organization of this unknowable, indescribable stuff that we start from. And furthermore, the organization, any laws of that natural world are imposed by us on this mind-created stuff. Now, you might say to Kant that you are not interested in the world we supposedly construct in our minds. You're interested in the real world. And Kant would reply, that which exists independent of our forms of awareness is inaccessible to the human mind. Or to put it in the terms that Harry Binswanger did this morning, the what is entirely inaccessible. We're trapped in a world of the how of cognition that we create ourselves. All we can know is this world of our own creation, the so-called phenomenal world in Kant's terminology. Reality, which he calls the noumenal world, is unknowable. Now, however, Kant adds, this is not bad news. Since we never experience reality, we have no reason to care about it. We live in the phenomenal world. To hell with reality. Now, this is the reason Dr. Peikoff has referred to Kant as the first complacent skeptic. It is radical skepticism combined with a don't worry, be dutiful attitude. Now, I want to illustrate Kant's complacent skepticism by discussing his views of space and time, which are obviously crucial concepts in physics. Now, Kant claims that reason is led into hopeless contradictions when it tries to transcend the phenomenal world and reach conclusions about reality. He gives several examples of such contradictions in the Critique. He calls them the antinomies of pure reason. Now, Webster's defines an antinomy as, quote, a contradiction between two apparently equally valid principles or between inferences correctly drawn from such principles. So an antinomy is a paradox. Now notice that the definition says that the contradictory principles are apparently equally valid. Without that qualification, this would obviously be an invalid concept, since there are no contradictions in reality. But that is not Kant's view. He claims that his antinomies are, quote, natural and unavoidable illusions which human reason must encounter in its progress, unquote. They are contradictions that we arrive at not because we made a mistake, but because we are trying to grasp reality and not humbly limiting our reason to the phenomenal world. Now, the first two of Kant's antinomies deal with space and time. And Kant's procedure is to present proofs for each of two contradictory views, which he calls the thesis and the antithesis. Now, let me give you his antinomy pertaining to space first. The thesis is the universe is spatially finite. Okay, Kant's now going to offer you a proof of that. And he begins his proof by saying, well, assume the universe is infinite. Then it would require an infinite synthesis to think of it, requiring an infinite time. Therefore, the infinite universe is unthinkable, therefore impossible. So the universe must be spatially finite. Now, that's a very bad argument, obviously depending on primacy of consciousness. But actually, we could give Aristotle's good argument for this same thesis, right? That the universe is finite. Aristotle establishes that by arguing that an actual infinity would violate identity. Okay, now, the antithesis. Kant is now going to prove that the universe is spatially infinite, after just proving that it was finite. Well, he starts out in his usual contrary rationalistic way. Assume the universe is finite, he says. Well, therefore, it must be surrounded by empty space. But empty space is nothing, and the universe cannot be limited by nothing. That would imply that nothing exists and limits existence, which is an impossibility. Therefore, the universe must be infinite. Now, Kant gives exactly parallel arguments for time, and it's probably not worth our time to go into it. I think that's enough to give you an indication of the way that Kant argues by manipulating floating abstractions. Now, Kant's primary intention here was not to prove anything about space, time, or the universe. He wanted people to accept his main conclusion, that reason self-destructs in contradictions when it attempts to grasp reality. Now, such contradictions are not evidence of a mistake, as I said. One must simply shrug and humbly accept the fact that our minds are incapable of understanding. We must limit ourselves to describing the phenomenal world. Now, we'll see later that this view of Kant's is essential to the accepted interpretation of quantum theory. For those of you who know some quantum theory, this is the ultimate source of the so-called principle of complementarity. But we get to that in the last lecture of this course on Friday. Now, while we're on the concept of space, I thought it was worthwhile making a general comment on Kant's views. There was prior to Kant, in the late 17th century, there was a major controversy between Newton and Leibniz on the nature of space and time. And both Newton's view and Leibniz's view, in my judgment, have elements of truth in them and also major errors. What Newton's concept of space was, he believed in what he called absolute space. And the error in his view is that he reified space into an independent existence. In other words, space is regarded as a thing in itself that exists independent of the matter and the objects in space. Now that is wrong. The correct aspect of Newton's view, though, is that the concept space is based on facts of the physical world around us. That the basis for the concept of space is external facts of the physical world. So so far as Newton believed that, he was perfectly right. Now contrast that with Leibniz's view on space. Leibniz rejected Newton's idea of reifying space into an independent existence. Leibniz argued correctly that the concept of space pertains to relationships, that space is not a thing in itself independent of objects. It is, in fact, a concept that pertains to relationships among objects. Space is, in effect, in Leibniz's words, the sum of places. And then Leibniz shows how one can derive the concept of place just from relationships among physical objects, which I think is the correct approach to the concept of space. Now, Leibniz's error is that, if you remember from your knowledge of history of philosophy, Leibniz was an idealist. In other words, he believed that the whole universe was made up of consciousness. So, and Leibniz had a very bizarre view in his idealism. In fact, he defined, what actually exists in Leibniz's universe are little atoms of consciousness that he called monads. So everything came down to these little atomic consciousnesses, which ultimately the concept of space reduced to. So in Leibniz's view, space, like everything else, is subjective and mental. So now, given that we have these two views that both contain an element of truth and also a major error, what do you think Kant does when he comes along? Absolutely. He purges every element of truth and takes the two errors, the one from Newton and the one from Leibniz, and combines them, and that gives him his view of space. So, of course, on Kant's view, everything is subjective and mental. The entire phenomenal world we create in our minds. So Kant is an idealist in that respect. So he takes that error from Leibniz and combines it with Newton's reification of space into something apart from objects. Because in Kant's view, space and time are created by a separate mental faculty, apart from the categories that supposedly create bodily objects. So he talks about space and time in the same way that Newton does, as if they were things apart from objects. So he manages to take the worst possible position, which probably doesn't surprise you too much. We'll see another example of this later in the course. Okay. Any questions so far? We're actually making good time. I'm starting to wonder whether I'm talking too fast. Yes, Brian.
I see the reification of space popping up over and over again in history. Do you think that is given rise to by the fact that we have atmosphere around us, and at an early age we discovered, oh yeah, there's this air stuff that didn't really exist before?
The question is the error of believing in, of reifying space, believing in absolute space, due to the fact that we have an atmosphere around us? I don't think so. Although I tend to think of this error as at least analogous to the kind of naive realism that that the early thinkers back in ancient Greece fell into in regard to perception, which I think is a very natural error. I almost think it's inevitable that people would have started out not accounting for the nature of our senses on the form of perception, and rather just thinking of perception as a revelation of the intrinsic properties of the object. Because that is the naive view. I mean, I think children probably start with that view. And in regard to space, in order to come to this relational view of space, I think you have to be somewhat, it requires some degree of sophistication to abstract from the bodily objects and see that, well, space is really just a sum of places, and I can define place with respect to relationships among those objects. You just tend to think that, well, there's this stuff between me and the wall, there's this, and I call it space. So I think it's natural. And in Newton's case, I actually have a good deal of respect for his arguments for absolute space. I don't think we have time to go into them today, but there is a famous argument that Newton gave for absolute space that is referred to as his bucket thought experiment that actually does prove something interesting, although it doesn't prove absolute space. And it took physicists 200 years to answer that argument. So that gives you an idea of how clever it was. Yes, Phil.
I don't want to generate a big argument, but I'm not so sure that the relational view is the correct view without giving up credence to whatever you want. In terms of objectivist thinking, if I understand it incorrectly, and I'm sure that I'd like to get a better understanding, but Harry Inslinger's own view doesn't seem to be that space is relational, i.e. there is no such thing as a void, and what makes the difference between 1 meter and 2 meter? You know, if you just had two things in the world, you know, where's the relation arising from in a three-dimensional space with two things there, if there isn't actually something there to give rise to a greater or lesser distance? So I'm not sure it's quite as clear cut in terms of a conclusion as what you're taking.
Yeah, the question is that we have a possible dissenter here on my view of the relational view of space, and Phil brings up some of Harry's past comments and wonders whether my view is consistent with Harry's, or okay, well that I think I can answer. I've talked to Harry on these issues several times, and to the best of my understanding, Harry and I are in agreement on the issues of space, the void, so on. So if anything I said you took to be in contradiction to what Harry has said, I would doubt that, but I'd have to talk to you about it after class, and I can. But okay. Well, let me. Did you have? Yeah. Yeah.
Even space, but yet didn't think space was existent.
Right. Yeah. Leibniz. In fact, if any of you are interested in Leibniz's views on space, let me give you the best reference, which is, I think, Leibniz's 5th letter to Samuel Clarke on this issue of space. And in those letters to Clarke, Leibniz talks more as a physicist. He simply describes the external world as it appears and how empirically we come to these concepts. And he has a couple of very good passages in my estimation. I hate to come across as a Leibniz fan because Leibniz was absolutely insane. But nevertheless, it's proof that insane people can write a couple of good passages. As soon as Leibniz gets more philosophical and starts bringing in his metaphysics, then you realize how crazy he is. But if he just describes the world as it appears and the way we build up empirical concepts, then he has good things to say. And then later you find out that he thinks that whole physical world is created by the consciousness of monads. So, is that?
So monads are mental.
Monads are mental. Right. Right. Okay, now let's go on with Kant's ideas here. And then what I'm leading up to now is Kant's physics. But I need to give you a few more comments before we're going to be ready for that. Now, Kant is very explicit that his anti-Copernican revolution requires the whole science of physics to be reconceived. Quote, "If nature referred to the existence of things in themselves, we could never know it. For then we would want to know the actuality of the thing itself in its existence outside our concepts." Unquote. Now, of course, it's impossible to know anything apart from our concepts. This is the standard Kantian argument. We grasp things by means of concepts, therefore we don't grasp the things. Only their subjective appearances created by our minds. Okay, so this is exactly what Dr. Benzwanger was talking about in this morning's lecture, that Kant replaces the what, the object of cognition, with the how. Because our consciousness has a certain nature and has to grasp things somehow, then we can't grasp the object out there. We only grasp the form in which it appears to us. So we only grasp appearances, not real objects. So Kant describes physics not as the science that studies the fundamental nature of matter, but as mathematics applied to appearances. Now, it has nothing to do with a physical world existing independent of us. Now, you all know that natural science began when the Greeks grasped the law of causality. And we've seen the way that Newton showed the full implications of the law of causality. So what does Kant think of causality? Well, it's one of his categories. That is, it's a rule by which our minds synthesize experience or create the appearances. Quote, "I comprehend the concept of a cause as a concept belonging to the mere form of experience. I do not comprehend the possibility of a thing in general as a cause, insomuch as the concept of cause denotes a condition not at all belonging to things, but to experience." Unquote. You get that? It's very clear. Causality does not pertain to entities out there. In the objectivist view, of course, causality is a relationship between entities and their actions. The actions are the effects. The cause is the nature of the entity. Kant is coming right out explicitly and saying, I don't comprehend the possibility of an entity being a cause. Causality is only a rule by which our minds synthesize experience. Okay? All right, now what does that imply about specific causal laws? For example, the basic universal laws of nature discovered by physicists. Kant writes, quote, "They are not derived from experience, but experience is derived from them." Unquote. In other words, such laws do not describe the nature of a world out there, but instead they are imposed by us on a world in here, in our minds, the phenomenal world. Now this is his Copernican revolution applied to physics. Now Kant's philosophy leads to a whole new approach to physics, a very anti-Newtonian approach. Kant rejected the basic premises underlying Newton's achievement. He rejected the efficacy of reason and the goal of understanding the real physical world. He rejected causality as a relationship between entities and their actions. And he rejected the idea that the basic laws of nature must be induced from observations. So all three pillars of Newton's philosophic legacy are rejected in total by Kant. Well, now what does Kant do now that he has destroyed the philosophic foundation for Newton's physics? Well, he decides to write his own book on physics. In 1786, Kant presented his approach to physics in a book entitled The Metaphysical Foundations of Natural Science. And the book was very influential on subsequent developments in physics. And so next time I will start by giving you some lowlights from it. And you will, well, I mean, you might be able to predict some of the things that Kant says about physics, because they do follow from his underlying philosophy, but I may have some surprises for you. So we have a couple minutes left. Are there any questions? Bob?
For Newton, was causality by entities explicit or only implicit?
I would say implicit. There was a definite positive, there was certain positive influence of Aristotelian scholasticism, which was still dominating the schools through the 17th century. And so there was Aristotle being taught, and this had some good effects, although one of the sad things in the history of science is that a lot of the 17th century scientists that led the scientific revolution thought of themselves as rebelling against Aristotle. And it was simply, the main reason was that Aristotle had been corrupted by the scholastics and was presented as a mixture of Aristotelianism and Christianity. And it was presented very dogmatically and rationalistically. And a lot of the 17th century scientists, precisely because they were scientists, were most interested in astronomy and physics. And of course, those are not Aristotle's strong suits. And they weren't sufficiently philosophic to understand the value of his basic metaphysics and epistemology while rejecting the rationalist dogma in his astronomy. But I think, there was that some understanding of causality, primarily due to Aristotle early on, and then it was completely corrupted in the 18th century because Hume came along and blasted entities and causality, and Kant came along with his Copernican revolution, which institutionalized primacy of consciousness. Okay, I think that's all the time we have, so I'll see you back here at 2 o'clock tomorrow. Thank you.
This course continues with Lecture 2.